average total cost and marginal cost and total cost all calculated in the table. So the next thing we're going to do is to graph the cost curves. We're going to graph total cost on one graph, and I'll label this axis by 50s. And then on the other graph, we're going to put both average total cost and marginal cost, and I'm going to label this axis by 3s. I want you to focus on understanding the basic shape of these curves, because I want you to recognize that the table problems and the graph problems are exactly the same. If we produce nothing, total cost is not 0. Total cost is 20 if we have 0 output. Then notice the x-axis is cakes. So we're going to skip on over to 20 cakes. And that's going to give me a total cost of 80. Then we've got 35 cakes for a total cost of 140. 45 cakes is 200. 50 cakes is 260. 53 cakes is 320. All right. So now the table problem gives you discrete numbers. We have a discrete production function. We can hire 1 worker or 2 workers, but not 1.5 workers. In the graph, we're going to just pretend that this is continuous so that I can connect the points so that you can just get a sense of what this line would look like if we had a continuous production function. We have an increasing cost function. Total cost goes up, obviously, the more you produce, but the important point here is that it's getting steeper and steeper and steeper. The additional cost of each unit is also increasing. And if you've had calculus, you can see that your marginal cost is actually the slope of the total cost function, or the derivative of the total cost function with respect to quantity. If you have no calculus, that's fine, don't worry. I'm going to plot marginal cost and average total cost on these graphs over here. If I hire 1 worker, I make 20 cakes. The marginal cost per cake is 3. Then I've got 35, 4, 45, 6, 50 is all the way up to 12, and then 53 is all the way up here to 20. So our marginal cost function here is increasing. This is the additional cost of each additional unit of output. Then we're going to plot average total cost. So our average total cost is going to be 4, and then 4, then just a tiny bit more than 4, then 5.2, and then 6. All right. The important thing to notice here, which is not maybe entirely clear from this graph, but hopefully it's a little bit clear from this graph, is that the average total cost curve is going to intersect the marginal cost curve at the minimum of the average total cost curve. Average total cost is usually going to look like a U shape. And at the very bottom of that U, the minimum, the very lowest point, that is where it will intersect your marginal cost curve. The fact that it intersects at the minimum, that's a general property of the marginal and average functions. It's not specific to costs. It applies to all marginal and average functions. But it will be useful to us when we interpret how different markets impact consumers in the future topics. The main takeaways are marginal cost is always increasing, and that's because we have decreasing marginal product, and the average total cost curve will intersect marginal cost at its minimum.